Now, one of the things we often hear is people will point to this glacier or that obscure glacier and say, look, this glacier is expanding, therefore, how can there be climate change? What's your response to that?
It's very hard to find a glacier that is expanding. Is the first thing. I know of more glaciers that have disappeared in the last decade than are advancing right now. So of course there's a lot more retreating, but still that's kind of an interesting juxtaposition. Uh, I've worked on one glacier that's been advancing of the 250 I've worked on, more or less continuously advancing over the last 50 years. And I've worked on at least a dozen glaciers that are no longer exist. And almost all of those, well, every one of those has disappeared in the last 20 years.
What
So
what
that'd be the
what would be a condition that would cause a glacier to advance in these times?
I guess I just, think of your bank account. If you finish paying off your mortgage on your house, your bank account's going to grow, and maybe it's been shrinking for the last 50 years. And so in this case, it's the Taku Glacier. It was calving icebergs into the ocean, and then it stopped calving because it was aground on a sediment plain that it built. And so it was just like finishing its mortgage payments. So now all it could do was melt, and it couldn't calve off any more icebergs. And so it's been expanding as kind of that adjustment. And so you'll see that at various glaciers. Anytime you have a glacier that calves into the ocean and the calving is shut off, experiences a reduction in calving. That's a change in its very budget. It may
Sure.
allow it in the short term to advance. It's unusual to have it happen in the long term.
Okay, as you mentioned, I was in Greenland this summer, and we saw a, a bit of a different kind of a year than, say, we've seen in the last six or seven. Not as large, it's still quite a large melt, but not a record melt like we saw in 2012. What is your take on what is happening in Greenland?
Well, if you put it in the context, if you compare 2012 to any year back in the 1980s or 90s, it's not going to look very good. If it's only in the context of comparing it to 2010, 2012, 2007, that it doesn't look as big. If you compare it to those other years, it's going to look like a pretty exceptional melt season. You're going to have to have a whole bunch of factors fall in the right place to be able to get a melt season like 2012. That's not going to be an every year event currently. Maybe 20 years down the line it will be, but right now we can't expect every year to be worse than the previous years. Just like in the North Cascade Glaciers, the year you joined us, snowpack wasn't that bad that year, and then last year was really bad. So again, it just not every place has a mild winter or a warm summer. Um, 2012, obviously very warm in the United States, our warmest year. And then now it's Australia's turn in 2013. And so Greenland's turn was 2012, not 2013. But the effects of 2012, the exceptional melting, will carry on. You did thin the ice, and that's not just going to rebound.
What is your take in general on? We had a new report from the IPCC, and they have bumped up their estimates of sea level rise, which is going to come in large part from ice sheet melt. Uh, they're looking at something like a meter of sea level rise by the end of the century. Does that sound like they've come up enough to reflect reality, or do you think that there is still some more adjustments to be made?
It's hard to forecast that far out. I think they had to come up some to be realistic. And of course, they're setting bounds, not just one number.
Right.
But uh, we've seen how rapidly things changed in the last decade from, since 2000 in Greenland with, if you look at the 210 outlet glaciers that reach the ocean in Greenland, 98% of those were retreating, and almost all those accelerated. And those two things are tied together. So that was a response that we understood would happen back in the 1980s. Was going to happen, or that would happen as fast or as synchronously as it did. But it's hard for us to then look ahead to 2030 and in a specific time frame understand how the Greenland ice sheet is going to respond. I mean, the clearest signal is that we know that as those glacier termini thin, there's less friction holding them back at the terminus of those calving glaciers, so they can calve more freely. And that's one way to retreat and lose volume. But as we've seen the last, and that's been the main way they lost volume from, say, 1995 to 2010. But since 2010, the actual melting has exceeded that. And so that's what we've seen is this kind of a transition. Is it a long-term transition or a shorter-term transition where melting is taken over as the more important? But they're still both very important. It's not like one is, you can ignore one without the other.
Okay, just to be clear, you're making a distinction between the icebergs that fall off at the face of a glacier, which is calving, versus you are saying melting, and many people might not understand that you're talking about just water that is running off the surface as a separate phenomenon from the glacier calving.
Right. There's just two different ways to lose volume.
Right.
And as you saw in 2012, we had the record melting probably, for many centuries in Greenland, and so that was the primary means of volume loss in 2012. In an individual year, say next year, you could have some large calving events that could alter that balance. This particular summer, 2013, we didn't have any big calving events. But it is interesting looking at how, I guess one of the things that's interesting to me, just from a geographic standpoint, is you're used to a map being correct. I mean, maybe a new road pops up or a new house. But when you look at glaciers or Greenland, the maps are just so wrong now because you see new islands everywhere around Greenland as the glaciers have retreated. And these islands that used to be embedded in the ice sheet are now just in the ocean, or in mountain glaciers, you see new lakes developing. And so we're really changing the very map of our world so fast.
Okay, one last question. We have a recent news item about a store of liquid water that has been found under the surface in Greenland, a fairly large area. Is that something you can tell us about?
Well, it's within the firn. So firn it's between snow, and everybody knows what snow's like when you go out and shovel it. And then there's glacier ice, which is pretty solid stuff. And firn is that transition from snow to ice. And so in that sense, it still has lots of pore space within it. And so meltwater generated from the surface can then trickle down into the glacier. And in certain areas, then, it's cold enough so that meltwater isn't really going to percolate down to the bottom. Maybe there's not well-developed hydrologic system. This is not an area where we have like meltwater lakes and streams and that kind of thing. So the meltwater isn't escaping; it's being refrozen within the pack, is what we generally think. But in this case, it wasn't refrozen; it was retained as actual meltwater. So, yeah, the glacier was acting as an aquifer for some meltwater. So at this point, it's interesting because we're still making new discoveries. On the other hand, I think the main thing this says to me is we need more field work to validate what we might, because we can't go out there and measure it in person across a big area. That'd be expensive, and as you know from Greenland weather, not entirely pleasant, safe.
Right.
So, but we need to use satellite instruments primarily, but we need more field measurements to validate the satellite imagery. Because at this point, is that a feature that's typically there, or is it a feature that was unique to the recent melt periods? Those are questions we can't answer at this point. So we're gonna have to take a look to better identify the size, the durability, persistence of that meltwater.